Hello everyone, welcome back to my channel Explain Maths. Now in this video I am going to solve the questions where you have to find the product using standard identities. Okay, now standard identities topic I have already covered in the factorization video. So I will request everyone to first watch that video and then come for this. Here I am going to solve only the questions which is based on standard identities. And here I will cover only question number 1 to question number 3 of exercise 9.5 which I have taken from the old Ncert textbook because I felt that those questions are really very important. Okay, and rest of the question I will cover in my next video. So let's begin the class. So first of all, what is an identity? So identity is an equality which is true for every value of the variable in it. Now what is the meaning of this? So I have given one example. This is one identity. I have taken a plus 1 into a plus 2 equal to a square plus 3a plus 2. Now if I see the definition, it says that it is an equality. Equality means having a equal sign, which is true for every value of the variable in it. Now if you see in this example, your variable is a. It means whatever value of a you will give, your LHS will become equal to RHS. Then we will say that this is an identity. So let's see one example. Let's put the value of a as 1. So if I put the value of a as 1, my LHS will become 1 plus 1 into 1 plus 2. Now 1 plus 1 is 2 and 1 plus 2 is 3. So 2 into 3 will give me 6. Now if I put the value of a as 1 in my RHS. So RHS is a square, means 1 square plus 3 into 1 plus 2. Now 1 square is 1 plus 3 into 1 is 3 plus 2. And if I add 1 plus 3 is 4, 4 plus 2 is 6. Now same way if you try for other values of a also, you will always see that your LHS is equal to RHS. So we can say that a plus 1 into a plus 2 equal to a square plus 3a plus 2 is an identity because it is true for all the value of the variable. Now let's see then what is the difference between equation and identity. In equation also we have a equality sign, right? Then what is the difference? So an equation is true for only certain values of variable. Okay, here identity we are telling it is true for all the values of variable. But equation, it is true for only certain values of the variable. So let's take one example. Now if I have given the value of, if I have given an equation like x plus 1 equal to 5. Now whatever value of x I will put, LHS will not become equal to RHS, isn't it? Only if I put x equal to 4, my LHS will become 4 plus 1, which is equal to 5, and your RHS is 5, isn't it? But if I put x as 0 or x as 1, my LHS is not becoming equal to RHS. So it means this is not an identity because it is true only for certain values of variable in it. So hope it is not now clear to everyone that what is the difference between equation and identity. So again I am repeating, an identity is an equality which is true for every value of variable in it. Whereas an equation, it is true for only certain values of the variable. Okay. So next we will see what are the standard identities. So these are the standard identities. A plus b whole square equal to a square plus 2ab plus b square. Then a minus b whole square equal to a square minus 2ab plus b square. A plus b into a minus b equal to a square minus b square. And x plus a into x plus b equal to x square plus sum of a and b times x plus ab. Now these standard identities, how it has come, I have already explained in my factorization video. Okay, here there I have given geometrical representation also. How geometrically you can find these identities. Okay, so I am requesting you all to please have a look on those videos first. Okay, so that's why I'm not explaining here again because I've already covered in my factorization video. So now I'm directly going to start with the questions which is based on it. So now exercise 9.5 question number 1. Use a suitable identity to get each of the following product. Now you have to find out which identity you will use. Now just now we have seen that there are 4 standard identities. Now which one will fit over here, and according to that only we have to find the product. So here I can write x plus 3 into x plus 3 as x plus 3 whole square, isn't it? And we have seen there was an identity a plus b whole square, which is equal to a square plus 2ab plus b square, right? Now, if I compare this with the question x plus 3 whole square, I can see my a is x and b is 3. Isn't it? If I compare this a plus b whole square with the given question, my a is x and b is 3. So I have to write like this in this form, a square plus 2ab plus b square. So my a square, where a is x, it will become x square plus 2ab, means 2 into x into 3, plus b square means plus 3 whole square. And if I solve it, it will be x square plus 6x plus 9. So this is question number 1, first part. The second one, 2y plus 5 into 2y plus 5. So again it will be 2y plus 5 whole square. Okay, again it is in the form of identity a plus b whole square. So which is equal to a square plus 2ab plus b square. Now here your a is 2y and b is 5. So 2y whole square plus 2 into 2y into 5 plus 5 whole square. Now 2y whole square will give me 4y square plus 2 2s are 4. 4 into 5 is 20y plus 5 square is 25. So this is the second question. Now third question. Now you all please pause the video and just think about it. Which identity you have to use over here. So if you can see here, your question says that 2a minus 7 multiplied by 2a minus 7. So this I can write as 2a minus 7 whole square. And we have our identity a minus b whole square, which tells that a square minus 2ab plus b square. So here your a is 2a and b is 7. So a square will become 2a whole square, then minus 2 into 2a into 7 plus 7 whole square. Now 2a whole square will give me 4a square minus 2 2s are 4, 4 7s are 28a plus 49. Next, moving to the fourth question, 3a minus 1 by 2 multiplied by 3a minus 1 by 2. So here I can write it as 3a minus 1 by 2 whole square, and again it is based on the identity a minus b whole square, which is equal to a square minus 2ab plus b square. So if you compare 3a minus 1 by 2 whole square with the identity a minus b whole square, your a is 3a and b is 1 by 2. So you have to write a square as 3a whole square minus 2 into 3a into 1 by 2 plus 1 by 2 whole square. Now 3a whole square will give me 9a square. Now here 2 and 2 cancel, minus 3a plus 1 by 2 whole square is 1 by 4. 1 by 2 square means 1 by 2 into 1 by 2, which will give me 1 by 4. We will move to next question. Now fifth question, 1.1 m minus 0.4 multiplied by 1.1 m plus 0.4. So here if I consider 1.1 m as a and 0.4 as b, so it will become a minus b, a plus b. And we have our identity, right? A minus b, a plus b, it is equal to, just now we have seen, right? A minus b into a plus b. This is our standard identity. This is equal to a square minus b square. So here your a is 1.1 m, so it will become 1.1 m whole square minus 0.4 whole square. Now we know that square of 11 is 121, but after decimal here is one digit. So 1.1 into 1.1 if I do, after decimal one digit is here also, here also. So 1 plus 1, 2. So it means you have to place the decimal point in such a way that after that it should have 2 digits. So you have to place it over here between 1 and 2. So it will become 1.21 m square minus 4 square is 16, and again you have to place the decimal point after 2 digits, because 0.4 into 0.4, in 0.4 one decimal place. So in both 0.4 if you see, one decimal place here, one here, so 1 plus 1 2. So you have to place the decimal point over here such that after that it should have 2 digits. So this is your answer. Now next question. A square plus b square multiplied by minus a square plus b square. So here what I can do, I'm not able to fit this in the identity because here is a square, here is minus a square, right? So, but we know that addition is commutative. So I can change the order. I will write b square plus a square, and here it will be b square minus a square. Now I can see it is in the form of a plus b into a minus b. A plus b into a minus b, where your a is b square and b is a square. It is equal to a square minus b square. So if I use that identity, it will become b square whole square minus a square whole square. So it will be b raised to the power 4 minus a raised to the power 4. So this is the sixth question. Now seventh question, 6x minus 7 into 6x plus 7. Again it is based on the identity a minus b, a plus b, which gives me a square minus b square. So here your a is 6x. So 6x whole square minus b is 7. 7 square. So it will give me 36x square minus 49. Next, a minus a plus c and minus a plus c again. So I can write it as minus a plus c whole square. Now I can use the identity a plus b whole square, which is equal to a square plus 2ab plus b square. Now here your a is minus a and b is c. So a square means minus a whole square plus 2 into minus a into c plus c whole square. Now minus a whole square will be a square, plus and minus will become minus 2ac plus c square. Okay, now this question you can do it in another way also. You can write the eighth question as c minus a, c minus a, because we know that addition is commutative, and then it will become c minus a whole square. So you can use the identity a minus b whole square and solve it. Okay, you are going to get the same answer. So you can try the another way. I am not solving it. You can try by yourself. Now ninth question. X by 2 plus 3y by 4. Again multiplied with x by 2 plus 3y by 4. So this I can write as x by 2 plus 3y by 4 whole square. Now it is based on the identity a plus b whole square, which is equal to a square plus 2ab plus b square. So it is equal to x by 2 whole square plus 2 into x by 2 into 3y by 4 plus 3y by 4 whole square. So 2 and 2 cancel. So it will become x square by 4 plus 3xy by 4 plus 9y square by 16. So this is the ninth question. Last one. Now these questions are not very tough, so you can pause the video and solve by yourself. So this question I can write as 7a minus 9b whole square. So you can see that it is in the form of the identity a minus b whole square, which is equal to a square minus 2ab plus b square. So here your a is 7a and b is 9b. So it will become 7a whole square minus 2 into 7a into 9b plus 9b whole square. So 7a whole square will be 49a square minus 2 into 7 14, and 14 into 9 will give 126 ab plus 9b whole square is 81b square. So this is your question number 1. It has 10 questions. Now I am moving to question number 2. Question number 2. Use the identity x plus a into x plus b equal to x square plus a plus b whole x plus ab to find the following product. Now see, in question number 1, you have to identify the suitable identity and then you have to find the product. In question 2, already they have given the identity. You have to use this identity only to find the product. So the first question is x plus 3 multiplied by x plus 7. So if you compare this with the identity which is given here, so you can see your x is x, a is 3 and b is 7, right? So If you want, you can mark it over here to compare. Your x remains x only, your a is 3 and your b is 7. Now try to use the identity x square plus a plus b whole x plus ab. So x square plus a plus b. Your a is 3 and b is 7 multiplied with x plus a into b, 3 into 7. So this will give you x square. 3 plus 7 is 10x plus 21. So this was the simplest question. Now you can see slowly there will be a variation in this question. So if you see the second question, 4x plus 5 multiplied by 4x plus 1. So if you compare with the identity which is given, your x is 4x, your a is 5 and your b is 1. So now let's use the identity. It says x square means 4x whole square plus a plus b. A plus b is 5 plus 1 multiplied with x. So multiplied with 4x plus a into b, which is 5 into 1. So 4x whole square will give you 16x square plus 5 plus 1 6. 6 into 4 24x plus 5 into 1 will give 5. Now third question, 4x minus 5 into 4x minus 1. So here you can see your x is 4x, your a is minus 5 and your b is minus 1. You can write b is minus 1 and a is minus 5. Now use the identity x square, which is 4x whole square plus a plus b means minus 5 plus minus 1 times x, which is 4x plus a into b means minus 5 into minus 1. So you have to do it slowly because you may do a mistake. There are negative numbers. Okay. Now 4x square will give you 16x square. Now if you add minus 5 and minus 1, you will get minus 6 and minus 6 into 4 is minus 24x plus minus 5 into minus 1 will give me 5 because there are two negative numbers. So the product of two negative number is positive. So this is your third question. Now fourth question, if you see here, one is positive and one is negative. So your x remains 4x, your a is 5, but your b is minus 1. Okay. So it will be 4x whole square plus a plus b means 5 plus minus 1 multiplied by x, which is 4x plus 5 into minus 1. So 4x whole square will give 16x square. 5 plus minus 1 will give 4 and 4 into 4 will give 16x and 5 into minus 1 is minus 5. So this is the fourth question. Now moving to the next question. Now fifth question, 2x plus 5y multiplied by 2x plus 3y, and you have to find the product using this identity only. X plus a into x plus b equal to x square plus a plus b whole x plus ab. So if you now compare this with the standard identity, you can see that your x is 2x here. Okay, so I'm going to write over here. This is your x, this is your a, which is 5y, and this is your b, which is 3y. So now use the identity. X square means 2x whole square plus a plus b. So 5y plus 3y times x times 2x plus 5y into 3y. So this will give you 4x square plus 5 plus 3 is 8. 8 into 2 is 16. So 16xy plus 5 3s are 15y square. Sixth question, 2a square plus 9 multiplied with 2a square plus 5. So here your x is 2a square, your a is 9 and your b is 5. So x square means 2a square whole square plus a plus b. So 9 plus 5 times x, which is 2a square plus a into b is 9 into 5. So this will give you 4. 2 square is 4. A square whole square will give a to the power 4. 9 plus 5 is 14. 14 into 2, 28 a square plus 45. Now the seventh question, xyz minus 4 multiplied by xyz minus 2. So this is your x, your a is minus 4 and your b is minus 2. So use the identity. X square means xyz whole square plus a plus b means minus 4 plus minus 2 whole x, which is xyz, plus a into b means minus 4 into minus 2. Now x by z whole square will give x square, y square, z square. Then minus 4 plus minus 2 will give minus 6, and then multiply with x by z, plus minus 4 into minus 2 will give 8. So this is the seventh question. Now we will move to next question. Now question number 3. Find the following square by using the identities. So first one is b minus 7 whole square. Now we have already solved these type of question. Remember when we were doing question number 1, we have done these type of question. So I want you all to please pause the video, find out which is the suitable identity and then solve it by yourself. And then later on you can check the answer. So if you see here, the first question says that b minus 7 whole square. So clearly we can see we have to use the identity a minus b whole square, isn't it? Here your a is b and b is 7. If I'm comparing this with my standard identity, your a corresponds to b and b corresponds to 7. Right? So now use the identity and find the product. So it will be a square means b square minus 2 into b into 7 plus 7 square. So b square minus 2 into 7 will give 14b plus 7 square will give me 49. So this is the first question. The second one, xy plus 3z whole square. Now this is based on the identity. Try to recall which identity. It is a plus b whole square equal to a square plus 2ab plus b square. So it will be xy whole square plus 2 into xy into 3z plus 3z whole square. So xy whole square will give me x square y square plus 2 into 3 6 xyz plus 3z whole square will give me 9z square. Now moving to the third question, it is 6x square minus 5y whole square. So again it is based on the identity a minus b whole square. So it will be a square minus 2ab plus b square. So it will give me 6x square whole square because your a is 6x square minus 2 into 6x square into 5y plus 5y whole square. So 6 square is 36 and x square whole square will give me x to the power 4. Then 2 into 6 is 12 and 12 into 5 will give me 60. X square y plus 5y whole square will give me 25y square. Now the fourth question, 2 by 3m plus 3 by 2n whole square. So again it is based on the identity a plus b whole square. So this will be equal to 2 by 3m whole square plus 2 into 2 by 3m into 3 by 2n plus 3 by 2n whole square. So 2 and 2 cancel, 3 and 3 cancel. So this will give me 4 by 9m square plus 2mn plus 9 by 4n square. So this is the fourth question. Now moving to fifth, 0.4p minus 0.5q whole square. So here again we have to use the identity a minus b whole square. Okay, so it will be 0.4p whole square minus 2 into 0.4p into 0.5q plus 0.5q whole square. So 0.4 whole square is 4 square is 16. So 0. Whole square will become 0.16p square minus, if I ignore the decimal, you have to multiply 2 into 4 into 5, right? 2 into 4 into 5. So 2 4s are 8, 5 and 8 5s are 40. And here you can see after decimal 1 digit, here also 1. So 1 plus 1, 2. So you have to place the decimal point here such that after that it should have 2 digits. So it will become 0.4 PQ plus 0.5 whole square will give me 0.25 and q square. Now moving to the last question, 2xy plus 5y whole square. Now again it is based on the identity a plus b whole square. So here I can write it as 2xy whole square plus 2 into 2xy into 5y plus 5y whole square. So 2xy whole square will give me 4x square y square plus 2 into 2 4. 4 5s are 20 xy square plus 25y square. So this is your question number 3. Now in my next video I will be covering the rest of the questions. So by that time keep practicing, and those who did not subscribe my video, please subscribe my video and share with your friends also. Thank you.